Hi, I am Syed Rashid. You are watching Ahle-Baid High School and Junior College YouTube channel. Welcome to my video to all students as well as viewers. Today just we are continuing our part 2 like intermediate first year like 11th class physics chapter number 3 motion in straight line. So in part 1 we have learned different things that what is like motion and what is speed, velocity, average speed, average velocity, instantaneous velocities, etc. Now in this session we will going to learn something about equation of acceleration motion, as well as we will going to solve few numericals related to this chapter. Okay, the equation which we are going to learn, this equation usually applicable only for uniform accelerated motion. Okay, and this equation you might have learned in your 9th class also. Here we have 4 equations with us. V is equals to u plus at. Okay, and we have s is equals or v square minus u square is equals to 2as. Okay, after that we have s is equals to ut plus half at square, and we have sn is equals to u plus a into like what we can say n minus half or n minus 1 by 2. So this 4 equation we have with us, but this is not the limit of this equation. If I want to write this equation, I can write this equation like this also. You can see here v minus u is equals to at. Okay, or else I can write this equation like if I want in terms of u, means I will going to write u is equals to at minus v. Okay, if I want this equation in terms of a, means I will going to write this a is equals to v minus u by t, etc. That means this is the basic of all the formulas which we can derive for these like things with us. Which things? The thing which is in rest or which is in motion. Okay, after that I can just write this in different forms. Okay, if I want only t, then I can write t is equals to v minus u by a. So you can see all the student and viewers, from the first equation I derive different 4 more equation. So I got totally 5 equation included these. Like this I can change this equation in different form also. Like I can write v square is equals to 2as, or else I can write v square is equals to u square plus 2as. Okay, if I want only v. In case I want only u, means I can write u square is equals to v square minus 2as. Okay, like that. If I want only a from this equation, means I can write s is equals to v square minus u square by s. If I want a, if I want s, means s is equals to v square minus u square by a. So you can see from a single equation we can derive multiple equations, but the thing is basic, you need to remember these 4 equation. I will going to read once again. V is equals to ut plus at, not ut. V is equals to u plus at. V square minus u square is equals to 2as. S is equals to ut plus half at square. Sn is equals to u plus a into n minus half. This equation we have. Now I am expanding what is here u. Okay, what is v, and v, u here is nothing but initial velocity. Okay, whereas for v we are considering as final velocity. Then we have a with us. A is nothing but acceleration, isn't it? Acceleration, acc. E, okay, I am changing the spelling of acceleration. We need to remember acceleration, acceleration. So a is acceleration here. Next what we have with us here, t. Okay, t we have with us like time. Okay, and one more thing we have with us, s. S is an special case. For s we are considering more things, like s is nothing but height, 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 or it may be considered as distance. Okay, distan, distance, or displacement. So this is an thing we are considering. So hope all the terms cover u, v, a, t and s. All the student and viewers draw. Now you need to copy this equation of uniform acceleration motion. After that you can copy these 4 equations. Okay, 1 2 3 4. After that you want to derive you can write these equations also. After writing these equation, you need to write the abbreviation. We can say like u is nothing but initial velocity, v is final velocity, okay, a is acceleration, t is time, s is height or distance displacement. Now the time to copy, which is written on board. Hope you have copied. We have one more type of equations with us, like kinematic equations, okay, kinematic equations of the uniform acceleration motion. For kinematic equations, we have v is equals to v naught or v0, we can read this, plus at, and one more equation we have s is equals to, we can say like v naught, okay, t plus 1 by 2, that is half at square. Here the same thing is nothing but v is nothing but here final velocity, okay, isn't it? V naught is initial velocity, okay, and what about other terms with us, like here you can see t is as it is time itself, no change in t. And what about x? Here x is nothing but displacement, okay. In previous case I said something about s, that s is height, distance and displacement. Here x is only displacement, okay, and same with us, like a is nothing but acceleration. So this also you have to copy these two equations, okay. Now we are moving to numerics. I am just standing few seconds here, you need to copy down these also. Here I am reading once again, v is equals to v naught plus at, x is equals to v naught t plus half at square, and you can read this as x is equals to v naught t plus 1 by 2 at square. Hope you have copied equation of uniform accelerated motion and kinematical equation of uniform accelerated motion. Now to solve some numeric, I am displaying question of numeric as you can see on the screen, okay. A particle moves in a straight line with uniform acceleration. Its velocity at time t is equals to 0 is vt, or we can say v1, and at time t is equals to t is v2. The average velocity of the particle in this time interval is v1 plus v2 by 2. Is this correct? Substantiate your answer. So hope you can you are seeing the question on screen. Solve, okay. And now I am not removing the question because I need to write few data, okay. Given what it is given, given that हमको क्या दिया हुआ है आप देख सकते हैं, बहुत आसान है. एट टाइम, ओके, t is equals to 0, what is the velocity, that is we can call it as initial velocity. Why we are calling it as initial velocity? Because it is a starting velocity. Initial velocity is nothing but we can say starting velocity, that is v1, okay. Now at time, okay, like we say t is equals to t, final velocity it is given. What it is given? Final velocity with us like v2, okay. Uniform accelerate, now we need to know one uniform accelerated motion. Uniform acceleration motion of the moving particle, of the moving, moving, moving particle, okay, is I said we have 4 equation with us. From that only we are deriving acceleration a is equals to, like we can say v2 minus v1 by t2 minus t1. Why we got this equation? I am explaining you. We have one straight line with us, say a or b, okay. Here the initial velocity is v1 at time t is equals to 0, or we can say time t1 is equals to 0. At point b, that is final velocity v2 at time t2 is equals to we can say like t. So from this we are deriving this equation, that v2 minus v1 by t2 minus t1, okay. Now we have one equation with us like displacement. For displacement we can use more than one type of equation, this PLA, CE, ME and T. Displacement we can use 2 types of equation with us, like v square minus v square is equals to 2as, and one more equation we can like use like s is equals to ut plus half at square. So in this case I am using like s is equals to ut plus half at square. So here s is as it is, okay, and whereas in place of u is nothing but initial velocity. We have initial velocity like v1, okay. Next, what is t? Here t is I am keeping as it is time, or else we can say I am keeping t as t itself plus half a is as it is, not as it is here. For a we need to write this. We have acceleration with us. I am marking this in the box. So for a I am writing v2 minus v1 by t2 minus t1 into like t square, isn't it? Now I am doing one more step. S is equals to v plus t plus half, okay. Here v2 minus v1 by t into t square. Why this t? Since we can write, okay, here since t2 minus t1 is equals to t. Why t means t2 is t itself and t1 is nothing but 0. So like t2 minus 0 is equals to instead of t2 I am considering only t. So just you need to write since t2 minus t1 is equals to 0 in this step. Hope you understood till here. Next, what I am doing, hope s is equals to, I am taking t as common, t1 as common, not t1, t itself I am taking common. So what I remain, v1 plus t is nothing but I remain as t, okay, plus half is as it is, isn't it? And instead of like here t is completely in cancellation, this t and this t get cancelled and this t already comes outward. So it will become like half into v2 minus v1, isn't it? How I got this step? This t square get cancelled, I remains only 1t, and this 1t and this 1t already taken as common here. So here I need to take, instead of t I need to take like v1. Why v1? Because we left with only v1 plus half as it is v2 minus v1. T is already on the outside of bracket. So it will become like t, this is v1, okay, plus just I am dividing this 2 with both, v2 by 2 minus v1 by 2. Next step, listen carefully. Here you can see this is v1 and this is v1 by 2. If I am removing 1 minus half, what I remain as half. So here also same case, I am remain with plus v1 by 2 plus v2 by 2. How I got? Complete v1 is removed from half v1. So it will become like this. Now one more step we need to go ahead, okay. S. Now this t goes to this, so it will become s by t is equals to v1 by 2 plus v2 by 2. So it will become v1 by 2 plus v2 by 2, or else we can take this as like s by t is equals to v1 plus v2 by 2. Therefore given problem problem is correct. So I am just CORRECT. I want to like explain once again this, okay. Now once again you can see the question here, because now I want to, few seconds ago there was a question going from this screen. So you might have saw that question. That question only once again I am repeating. Here the case is a particle, okay, is moving from like with uniform acceleration from t is equals to 0 at initial velocity v1 to t2 is equals to 2 at the final velocity v2, and it is, the problem is asking the average velocity of the particle in this time interval is v1 plus v2 by 2. So is it correct statement or wrong statement? We need to justify that, okay. This is the thing. So for that what I did, like given that at time t is equals to 0 initial velocity v1, at time t is equals to t final velocity is equals to v2, uniform acceleration motion of the moving particle is a is equals to v2 minus v1 by t2 minus t1. Displacement, we have one equation with us like s is equals to ut plus half at square. S is equals to, in place of u what I write, v1, in place of t is t as it is, plus in place of 1 by 2 is 1 by 2 as it is, in place of a what I wrote, a is equals to v2 minus v1 by t2 minus t1 I wrote, and t square is as it is. Next step what I did, t v1 t plus half v2 minus v1 by, here t2 minus t1 is nothing but t itself, so I wrote t into t square. Here t and square get cancelled, we remain only 1t like here outside the bracket. So now next step I have taken t as common, so I remains like v1 plus half, okay, v2 minus v1 bracket close. After that what I did, t is as it is here, v1 also as it is, I am just open this v2 by 2, after that minus v1 by 2. Now I have v1 minus v1 by 2, 1 minus half what we have with us, half itself, so that's only I wrote v1 by 2 plus v2 by 2. After that what I did, this t goes to the denominator left hand side, this become s by t is equals to v1 by 2 plus v2 by 2. S by t is equals to, here I am taking 2 as common, that is v1 plus v2 by 2. Therefore the given problem is correct. So this is an easy problem, but you need to practice more than one time. So as of now you can copy down this problem, question already went from your screen, you can rewind this video and copy down the question, okay, answer is on board. So that's all about our today's session and today's class. We will going to continue our same motion in straight line in our next session. So till then, take care. I am Syed Rashid. You are watching Ahliabad High School and Junior College YouTube channel. Make sure practice more than one time. Have a great time. Thank you.